So now we are going to solve the 2024 Sedimentary Geology PYQ, and we are going to solve this in a reverse manner. So there are total 12 questions and we are going to start from the 72 question. So during diagenesis of carbonate rock, हमेशा ध्यान देना, in a sedimentary geology paper, you always see that the diagenesis of the carbonate rock, it just happens to be in the last of it. So during diagenesis of carbonate rock, transformation of mineral to itself or to a polymorph is termed as what? So there are key phrases. Diagenesis of carbonate rock, that is the first one. Transformation of one mineral, that is the second one. And to itself or to a polymorph is the third one. Okay. So neomorphism, what is neomorphism? So this neomorphism is a diagenetic process that involves the process of recrystallization, like same minerals to the same minerals, but there are changes happening. Inversion, that is a mineral to a polymorph. Okay. So neomorphism is an umbrella term. The component of neomorphism is recrystallization, in which the crystal size or texture change, but there is no chemical change and the same mineral is there, like there is a micrite to sphaerite. So this is known as recrystallization because that is a micro crystalline calcite and that is a coarse calcite, and the inversion is the same chemical composition but different crystal structures. Okay, now we have to go through this aragonite to calcite. So neomorphism is the correct one, and but the replacement is something that one mineral getting replaced by the another mineral, like calcite is replaced by silica, so it to itself or a polymorph. Recrystallization, one mineral to itself, and it does not includes any polymorphic change, and inversion only polymorph change, and that is too narrow. So neomorphism is the correct answer. Now coming to the 71st question. A lahar is a debris flow that contains a significant proportion of material of volcanic origin. Statement 2 is lahar is formed as a result of mixing of unconsolidated volcanic material with water and subsequent movement of the dense mixture as a sediment gravity flow. So lahar, what is lahar? Lahar is a volcanic debris flow. There is ash, there is pumice, there is rock fragments, there is water, and they just move downslope among the valleys. How lahars form? So there is this unconsolidated volcanic material, the water comes in, and the gravity driven flow happens. So water source includes a heavy rainfall, a melting snow ice during eruption, breach of the crater lakes. So this explains why the lahars are the debris flow containing the volcanic material. So with this, a lahar is a debris flow that contains a significant proportion of material of volcanic origin, that is correct, is a result of mixing of unconsolidated volcanic material with water and subsequent movement of the dense mixtures. Both the statements are correct. Statement 1 describe what lahar actually is, and statement describe how lahar is actually formed. Okay. Also, the lahars are extremely destructive in nature. They can occur during long or after the eruptions, and they follow the pre-existing river valleys that are already there, and they travel 10 to thousands of kilometers. And pyroclastic flow is not that equal to the lahar, because pyroclastic flows, they are hot and gas supported, and lahar is water rich and gravity driven. So I've told you what can be the sources. I will again tell you the sources can be heavy rainfall, a breach of crater lake, and the melting of snow and ice during eruption. So both the statements are true, and both the statement are true, and the statement 2 correctly explains the statement 1. So option A would be correct. Now, coming to the 70th question. A broad expanse of unconfined sediment laden run of water that moves downslope and alluvial fan surface at the times of the catastrophic discharge is known as what? So Okay. There is a broad expanse of unconsolidated sediments laden run of water that moves downslope in alluvial fan surface at a time of catastrophic discharge is referred to as what? So there is a core concept. An alluvial fan is formed when a high gradient stream exits a mountain front and and loses confinement and energy. So different flow process operates on fan. They can be the channelized flow, it can be debris flow, it can be sheet flood. Sheet flood is thin, literally extensive sheet of water, and the flow is unconfined. There is no channels in it. It is short lived, like not much time is required, and there is a high sediment load in it, and it occurs mainly during when there is an intense rainfall and when the flash floods in arid to semi-arid region occurs. So what kind of sediments it deposits? It deposits poorly sorted, of course, poorly sorted sand, silt and gravel. Thin and literally continuous layers are there, weak or absent internal structure, and common on the middle or distal part of the alluvial fans. So the why the broad expanse is the key phrase in here is because it is a lateral spread, and unconfined means there are not in channels, and sediment laden means the sediment laden means that the transport and deposition is occurring together. So there are three uniquely defined sheet floods. Why other options are not working? Because debris flow is viscous, it's matrix rich, supported, channelized. Inside channel flow is confined channels in it. It's not unconfined sediment later runoff or etc. And mud flow is fine grain. Mud flow or landslide is what? Landslide is like collectively occurring as a cohesive node, broad sheet runoff like that. Now coming to the 69 question, Hamada are the rocky terrains with vertical cliffs and flat rock surfaces in what? So they are something that are present in desert. Bajara is something that is present in alluvial plains or so. Okay, but Hamada is in the desert. It is characterized by the exposed bedrock, rock pavements, steep scarps, and plateaus. Hamada forms by the intense mechanical weathering. The wind deflation is something that removes the fine material and just leaves behind the bare rock surfaces and resistant bedrock in it. So Hamada is a bare rock that is dominant material in the Hamada. In reg, gravel, and in erg, it's sand. Okay. Now, the climate setting that required is arid to hyper arid climate. There should be no rainfall and high temperature inversion. Why not other environments? So glacial is something that produces still, not bare rock pavements, and coastal is something that has this wave dominated features, and fluvial is a channel deposit. So yeah, now coming to the 68th question. Quartz arenite is a sandstone that contains what? So quartzite is a sandstone that contains at least 95% quartz and less than 15% matrix. So there's this sandstone classification of DOT 1964 given, and it is done on the basis of the framework grain composition, the matrix percentage, and the textural maturity. So quartz arenite is most compositionally mature sandstone, and it can have a cement made up of silica or carbonate. Why such high quartz content? Because of the intense chemical weathering that has been occurring, long transport distances there, and multiple cycle of reworking is there. So there are this unstable minerals like feldspar lithics are destroyed. Depositional environment, commonly they are associated with beach and shorefish and shallow marine shelf, Aeolian dunes, and passive continental margins. Why other options are wrong? Because of the first option, it can be the subarcos or the lith arenite. More than 15% matrix is something leads to the grey rock or so, and presence of feldspar, it causes the presence or results into the arcos. So coming to the 67th question, another question based on the shear classification, and this one is the Classification of the limestone. So, based on the depositional texture, an allochthonous limestone with mud supported fabric more than 10% grains of this size is termed as what? So, there was this Dunham classification given in 1962, and it is the mud versus grain report, presence of lime mud and grain percentage. So, allochthonous limestone is the one that we need to decode, means grains are transported and allochems are present. Now, mud supported fabric is like lime mud forms on the framework, and more than 10% grains, 0.03 to 2 mm size is a significant allochems that we get, like oids, pellets, and fossils. So, mudstone. So there is this mudstone, and it is mud supported, and the grain is less than 10%. If there is a wax stone, the grain is more than 10% and it is also mud supported. But in pack stone and in greenstone, they both are grain supported. Mud is present, then it's pack stone. If no mud is present, then it's the greenstone. So wax stone is the one that perfectly fits over here because mud is mud supported and it has 10% grain and it is allochthonous in nature. Packstone is the grain supported. Floatstone is used in Emery and Cloven classification, not the Dunham classification. Also, the greenstone has no mud in it. Okay. Now coming to the 66th question. Small lenses of sand in muddy beds form when sandy ripple is trapped in the muddy substrate are called what? So they are called the lenticular bedding. Lenticular bedding is something that occurs in a mud-dominated delta or tidal environments, and the sand occurs as an isolated lenses within the muds. So it forms when sand ripples are preserved as lenses during brief high-energy phase, then get buried by the mud. So flazer bedding is the sand-dominated, mud has drapes, and wavy bedding is the equal sand and mud, and lenticular is the mud-dominated. So small lenses of sand and muddy beds, it likely leads to the lenticular bedding. But this herringbone cross strata, this is something that is present in the tidal environment. Now coming to the 65th question. The paleocurrent vector data from sedimentary rocks are commonly plotted on a circular histogram. The diagram is called what? The diagram is known as the Rose diagram. So there is a paleocurrent data that record the direction of the ancient transport sediments obtained from what? So there is a cross bedding, there are ripple marks, there is imbricated clast, then there is flute and groove cast. So these are the direction vector data. Cross bedding, ripple marks, imbricated clast, and flute and groove cast. Okay. Now there is what is a rose diagram. It is a circular histogram that shows the frequency of directional data. Each petal is one that represents the direction, azimuth, and length proportional to frequency, and it is something that is extensively used in the paleocurrent analysis, structural geology, and wind and wave studies. Why rose diagram is correct? Paleocurrent data are directional. Circular plotting avoids directional bias, and it is a easy identification of dominant flow direction and bimodal or polymodal flow. Flower structures is a strike slip for geometry. Fence diagram is a 3D. Stratigraphic correlation and pie diagram is the percent data, not the directional vectors. Now coming to the 64th question. So rarely migrated sand ridges in an aeolian environment with unusual heights and in alternate opposite direction is known as what? Is known as the reversing dunes, because the key things that we need to hear is rarely migrated, which means there is limited net movement. Unusual heights is vertical buildup is happening. Alternative opposite directions is the wind reversal. So what are the reversing dunes? Reversing dunes are forming under the bidirectional wind regime, and the wind blows in the two opposite directions. Slip phase alternate sides, the net migration is minimal, so dune is something that grows vertically instead of horizontally. Star dune is the one that has a multiple direction winds, more than 3 direction, and it has this pyramidal shape that is happening and not alternating opposite direction. Sieve dunes is the longitudinal one, and that is formed under the unidirectional wind. Long linear ridges are there and they migrate significantly. Parabolic dune is U-shaped, anchored by the vegetation, and they occur in coastal or semi-arid areas. So yeah, coming to the 63rd question, which one of the following method of grain size measurement is not preferred for unconsolidated fine size sediments like fine silt and clay? So obviously the answer over here will be sieving, because sedigraph, pipette analysis, laser diffractometry is something that is easily used for the unconsolidated fine size sediments. So sieving is the one. So grain size analysis, it's something that usually depends upon the particle size range. If the gravel and sand is there, then sieving can be done. But if the silt and clay is there, then the settling based or optical based method is done. Fine silt and clay particles, they are too small to pass through that sieve meshes effectively. So they show cohesion and electrostatic attraction, and it leads to the poor separation and large analytical error. So sieving is unsuitable for fine sediments. And the sedigraph is something that uses the X-ray attenuation, and it is based on the Stokes law and highly accurate for fine silt and clay. Pipette analysis is classic method, and it measures settling velocity in suspension, and it is widely used for clay size fraction. Then we have this laser diffractometer. It measures the light scattering by particles, and there is this rapid and precise, and it is excellent for fine size sediments. So sieving is common and familiar. Students over selected, but fine sediments require settling or optical techniques. 62nd question. Three straight line segments are ideally demarcated when cumulative percentage of sediments having normal grain size distribution is plotted on the log probability. Which one of the following is the correct ascending order of incidence among the three line segments? Concept is very important over here is when cumulative grain size is plotted on a log probability paper. Sediments with normal distribution shows these three line segments. Each represents a transporting population. This is something that was given by the Vischer in 1969. Okay, so three populations are, there is this traction population, जो सबसे ज़्यादा कोर्स ग्रेन होते हैं वो रोल और स्लाइडिंग के थ्रू ट्रांसपोर्ट होते हैं, और ये हाई एनर्जी कंडीशन में ट्रांसपोर्ट हो सकते हैं, and they appear at the course end of the plot. So if the coarse grains are there, so it will be at the coarse end. Saltation is something that we get by the medium grain size, and they are transported by the bouncing, like they are dominant in fluvial and in aeolian amine, and there is a central segment of the plot. Okay, that is saltation. And suspension is the finest grain size, and that is something that is carried in water and air. They deposit during low energy, and they appear at the first fine end. So like this. So ascending order of incidence means like from coarse to the finest grain population order of incidence. So traction, saltation, and suspension. Okay. Now coming to the 61st question and the last question, calcite, gypsum, and apatite are termed as what? So will they be termed as a carbonaceous, siliciclastic, chemical, biochemical, or heterogeneous? So they will be termed as a chemical and biochemical constituent, because sedimentary rocks are being classified on the basis of their constituents too. So there is this heterogeneous, siliciclastic, quartz, feldspar, and lithic fragments are there, and they have been derived from the weathering of the pre-existing rock. Then we have this chemical and biochemical. They are the minerals that had been formed by the precipitation from the solution, and inorganically or by organisms like chemical or biochemical way. Calcite is CaCO3. It is formed by the chemical precipitation of evaporitic substances like carbonates, and there can be the coral shells or foraminifera. They are dominant mineral in limestone. And the gypsum is the evaporite mineral, and they precipitate from saline water during evaporation, entirely chemical sediments. And the apatite is something that occurs in the phosphorite and biogenic remains, and it is chemical and biochemical in nature. So yeah, with this I would end this video, and I hope that I have answered the questions, and you can read more about these topics that are frequently asked Only then you will be able to increase your marks. Thank you.